Okay, so let's build a really big LAN. So what we're going to do is we're going to take our computer up here. Now I could do Control C, Control click, and I could get lots of these PCs. I'm not going to do that because each of these PCs hasn't got DHCP set. So what I actually want to do is I want to get one PC. I want to just go into the config fast Ethernet interface and set it to DHCP. So this computer here now has got DHCP set. So I can Control C to copy that, and I can Control V to paste it out, and I can basically get myself a whole load of computers and build myself a local area network. Now we're only limited by how many can connect to our switch, so I'm not going to go completely overboard, but this will work better if you get at least kind of 10 or more PCs in our network. So that's probably enough to do one more. Okay, so there's our network. All these PCs now set to DHCP. Remember, to build a LAN, what we need to do is we need to put a switch at the middle of our network. So there's a switch. Remember what a switch looks like. It's got all these ports where we plug our cables in, and to give all these devices IP addresses we need to go and get a server. So here's a generic server. Remember, a server is just another device on our network. Go into the server, go to config, and go to services, and go to DHCP. This is where our server is. It's not got a pool of addresses yet because we haven't given it an IP address. So we'll go onto here, go to config fast Ethernet, and we'll give it an IP address. Obviously a server can't give itself an IP address, it needs something to start with. And we're just going to use a different range this time, 192.168.7.1. So all our network addresses must start 192.168.7. something. And we need to connect that in. So I'm going to get my cable here and connect my server in from fast Ethernet. Doesn't matter where I plug it in. I must admit I tend to plug it in down the end so I know where it is. Let's just fast forward time. Come on, fast forward time. There we go. So if we now connect one of our PCs, so we've still got straight through cable, let's just connect one of our PCs up to the switch. Fast forward time and see what happens. If we hover over the PC, you'll notice it's a 169 address. Now that's what's called a self-assigned address. The PC has been firing out DHCP requests, but nobody's been replying, which is a bit odd. Why has it not been replying? Well, if we go back to our server, go to services and DHCP, whilst here you can see the pool of addresses is 192.168.7 something, we didn't switch the server on. So let's switch the server on. So this now has got IP addresses. Go back to our PC, it's still a 169 address. Let's try and fast forward time a bit, see if that works. 192, there you go, it's renegotiated. So all the PCs, when they connect, if they can't find the DHCP server, they'll self-assign, and over time they will renegotiate. If you need to force them all to renegotiate, you can just power cycle all the devices down here. So I'm just quickly going to go around and connect all the devices. So remember to do that, I press Control and the straight through cable, and that means as I select each one in turn, it's still got the cable connection allocated. Okay, and here's our last device being connected up now. Excellent. You can see they're all links all coming up. Let's just force time forward. They're all allocated. Let's just see if they've got IP addresses. 169 self-assigned. Let's fast forward time, see if that gets it up. There you go, 192.168.7.11. So they've all got addresses. They happen to be sequential, probably because that's the order I connected them in. So we've got our one local area network. Now what we want to do is imagine a scenario where we've got a second local area network. So I'm going to copy all of those, Control C and Control V. Here's our second network. I'm just going to move the PCs around a bit in our second network. Now because we've made a direct copy of the first network, obviously what's happened is the server is the same, the address ranges are the same, everything is pretty much the same. Just let's fast forward time, and obviously if we have a look, these addresses are so they're still self-assigned. Let's just fast forward time again. There we go. No, it's still self-assigned. Come on, fast forward time. There you go, 192.168.7. So they're all the same as the ones over here. Now, if I want to connect these two networks together, what we could do maybe is you'd think make these a different address, 192.168.8 dot something. But the rules are quite simply on a LAN, all the IP addresses need to be in the same range, so they've all got to start with the same first 3 numbers in our case, 192.168.7. So it doesn't make sense having 2 separate DHCP servers. So what we'll do is we'll get rid of that DHCP server. So now we've only got one, which is this one over here, and we're going to connect our 2 networks together. The way we can connect them is basically a cable between switch ports. Because we're connecting 2 switches together, we actually need this one here, which is a crossover cable. So we'll connect this again. It doesn't actually matter which ports, but just so I can be logical, I'm going to select it between 23 on both my devices. And fast forward time, a bit more. There we go. All our links have come up. Now at the moment, I'm guessing these IP addresses, yeah, they're still in the 7 dot kind of lower ranges. So these have still got their IP addresses from their previous allocation. We can probably try and fast forward time a few goes. Let's see if that's forced them to renegotiate. No, it's still 7.2, so they haven't let go of their old IP addresses. What we should be able to do is power recycle all the devices. I'm just going to say yes to that. There you go, everything's gone down. Let's fast forward time. Stuff's coming up slowly, all the links have come up. So now if we look at these IP addresses, oh, they're still self-assigned. Just sometimes takes time for this to happen. There you go, 192.7.20. So I'm guessing now they've all got different IP addresses, 7.8. I could go around and prove that. But basically I've built a big LAN by interconnecting 2 LANs and basically made a bigger LAN. It all seems to be pretty fine. And you would think we could go on ad infinitum with this until we run out of numbers. And obviously on the network we've got at the moment, after the 7, you can have anywhere between the number 1 and 254. So we could put a lot of devices on. But just bear this in mind. Let's just get one more PC. Imagine a new PC joins our network, and remember this is about a new PC being switched on. So here's a new PC. We want to connect it up onto our network. So we connect it in to one of the ports. That's Ethernet 11. Let's fast forward time. Now remember, this generic PC will be set to static, so there's no IP address, and I want to turn it on so it uses DHCP. Actually, yeah, I'm going to leave it connected in there. But what I want to see is what the effect of this has on my traffic. So I'm going to turn all the filters off, and I'm just going to look what happens with DHCP. So I'm filtering on DHCP traffic now, and we've got this PC here. And I'm going to go into the config, I'm going to go to the fast Ethernet, and I'm going to turn DHCP on. Okay, so there you go, here's the packet. And let's just have a look what happens when we run DHCP. I'm going to hit play. So it goes in to the switch. Remember, it's a broadcast, so it has to go out. Remember where a broadcast goes out. It goes out everywhere, so everybody gets it. Notice it also came over to the other switch because it was broadcast, and that means broadcast everywhere. So that request went everywhere on our network. Okay, it did get to the DHCP server, which did reply. Remember, the reply itself is a broadcast, so the reply goes everywhere. Alright, everybody's ignoring it, but it's still taking up bandwidth. There you go, and then there's our response coming back in. The response is also broadcast, and then the final reply coming back in, and the final reply is broadcast. Wow, look how much traffic that generated because it's a broadcast message. There you go, I think that's finally finished now. There we go, and if we look at our PC now, hopefully, yeah, it's got its address. So when we've got a big LAN network like this, any broadcasts are just broadcast across the whole network. The whole nature of broadcast means they are broadcast across the whole LAN. Whilst the PCs themselves then don't take up any time processing that because they ignore it, it all uses up bandwidth in the network, and all the computers have to at least look at it to decide that it's not for them. So it wastes resources. And you can imagine in a much bigger network, all the broadcasts that go around, and DHCP is not the only protocol to use broadcast. Lots of other things use broadcast to discover the network. it would basically make the LAN untenable. And we see this many times. People build really big LANs by interconnecting switches. They appear to work, but they just get more sluggish and sluggish because there's more and more broadcast traffic running across the network. So it's not the way how we interconnect networks.